Imagine you are throwing a massive party to celebrate your Class 11 results. You decide to cook the entire feast yourself. You throw the cake batter, the raw rice, and the spicy curry ingredients into a single giant pot, boiling simultaneously. It is a guaranteed disaster. To actually feed your guests, you have to separate the meal prep. You set up neat, isolated stations, one strictly for chopping vegetables, one for boiling rice, and a separate oven for baking the dessert. Each task is independent, but they all contribute to the final meal. Writing a large computer program operates on the exact same logic. If you write hundreds of lines of code in one massive, continuous block, it becomes difficult to track errors or update features without breaking the entire system. To maintain control over our code, we use a strategy called divide and conquer. By breaking a massive script down into smaller, isolated units, we ensure each part of the program is manageable. Methodical. Open your Python environment. For this exercise, you will need a basic working knowledge of variables, loops, and conditional statements. We are going to start with a standard script designed to generate a student report card. It prompts the user for a name and marks, calculates the math, and prints the result. Right now, it is one long, unstructured block of code. Our objective is to dismantle this script entirely. We will rewrite it into a program using independent blocks called functions, showing how modular design keeps code clean and easier to control. Look at the starting script. Every command runs in one continuous stream. We can isolate 3 distinct jobs. First, gathering the student's name and test scores. Next, calculating the total, percentage, and final grade. Finally, printing the text-based report card. Because the script is performing 3 distinct jobs, we will create 3 separate structural containers to organize them. Step 1 is building our first container. Type DEF, short for define, followed by the name input details and a pair of parentheses. This tells Python we are creating a new function. Move the input code into this block, ensuring it's indented with a tab. To push this trapped data out, add return name marks at the bottom. Next, build calculate result marks to receive those returned test scores for the math. Take the sum and percentage calculations, along with the grade conditions, and move them inside this second function. Complete this function by writing a statement to return the total, percent, and grade variables back to the program. The program now relies on 2 self-contained machines, one dedicated to gathering data and another dedicated to processing it into a final result. For the final container, we create a function called report, designed solely to print the formatted strings. Notice this output function doesn't need a return statement. Its final action is projecting text to the screen, rather than passing data back. We currently have 3 disconnected blocks. To run them, we create a distinct area at the bottom of the script called the main program. This acts as the master controller that orchestrates the functions. First, call input details. We catch its returning outputs by assigning them to variables on the left. Now, feed those marks into calculate result. The function processes the math and hands back the total, percent, and grade. Pass all of those gathered variables into the report function to trigger the physical printout. The tangled, monolithic script has been replaced by a readable, 3-line master sequence. Run the newly assembled program. The console sequentially prompts for the inputs, executes the math logic, and generates the clean document on the screen. By dividing the program into independent blocks with different names, you have applied what computer scientists call modular programming, or the stepwise refinement method. If you need to add a new subject like history, the adjustment is isolated. You simply alter the input list in the first function, and the math and print functions will adapt automatically. This structural flexibility makes the code much easier to update and debug. An error in the math calculation will not interfere with the data collection process, making the program more resilient to changes. You start with independent pieces. By defining what enters and leaves each block, these parts lock together to build a stable and organized program.